I'm going to start over what we did today in class and then continue on with getting started with a control chart to monitor QC spike results. You might start out like this if you were stuck by yourself in a lab and you were starting on your research project. You know you're supposed to include spikes with every batch. You might have done a couple duplicate spikes. In any case, you've got 10 results and you want to make a control chart. And the quiz asked you to list the steps today, and you guys had very good answers. A little confusion here and there, but for the most part, everybody had the right idea. So what we're going to do is create random numbers to generate a fake data set. And we're going to do random numbers with a formula in the Google spreadsheet. And then we use formulas to find the average and the standard deviation. We're going to use something called named ranges to write our formulas because this is easy and it's good to know. And then we set these numbers up for our control limits and warning limits in a table in such a way that the table helps us make the chart. We just select the table and we get the right kind of chart. Then we're going to look at a little bit at formatting, sprucing it up in various ways. And once you have the chart made with the, I'll insert what it looks like, then you want to put the real date into the chart. And I'm going to do this in a way that, looks like it wasn't planned from the beginning exactly how it should go, because that's probably the way you're going to do it, and it's certainly the way I do it all the time. I noticed that there's a little thing here I'll show you, and then once we get our real data, in other words, these are numbers that we're going to collect in the future and evaluate on the control chart that we make from these results that we've already collected. So this is sort of an initial set. Then we use the control chart to monitor our real data thereafter. Okay, we're going to look at that real data, and you'll see. We'll go on with this a little bit. All right, so I'm going to start over actually with a new file because when I named my ranges for mean and standard deviation, I had to create kind of awkward names, so we're going to get my sheet kind of like your sheet. Okay, equals norm inverse random mean of 100, standard deviation of 10. Okay, this will be our spike, recovery, microgram per mil. And this is the batch number. And I do this like this, 1 equals 1 plus this, Control C, Control V. I could have done this too the same time. Delete. 10 results. Okay, then up here, let's insert a row above, insert R. We're going to have the average and the standard deviation. Let's just call this AVG. Okay, equals average of these guys. Enter. Equals SDDEV of these guys. Those are the required formulas. Enter. Okay, now we're expecting to see 10 here. That's a little on the low side. Okay, now I'm going to format these, put them in the middle, but bring down the decimal points. Something more reasonable. Okay. I'm showing you some formatting things that don't hurt to know. Alright. We'll put these on the right hand side. Alright. Now, this is, I showed you how we could say equals S. Oh, now I need to name these. So we go here and I say data, named ranges, add a range. Add a range, this is B2, right here, B2. So we're going to call this SD, and here this is another range, B1, we're going to call that AVG. Now we've named those two things, now we can use them. So I'm going to set up a table here. This will be kind of our batch number again for the future, okay? But this is just our control chart. So I think they start on top. Upper control limit is on top. We'll see. Upper warning limit, the average, the lower warning limit, and the lower control limit. By arranging these the right way, we can have it work automatically. Now, the upper control limit equals the average plus 3 times the standard deviation. And the upper warning limit equals the average plus 2 times the standard deviation. And this is just equals average, and this is equal to the average minus 2 times the standard deviation, and this is equal to the average minus 3 times standard deviation. Whoops, I forgot the equal sign. Here's something to tell you. F2. Hit the F2 key, that automatically puts you in edit mode. Hit home to go back to the beginning. This is really helpful. Notice when I put an equal sign in, it starts lighting that color up. This is the orange. This is purple, but you can't really see it very well. Yeah, there it lights them up as we touch them. I just hit enter. Okay. Now, we're going to have this go from batch number 1 to batch 100, okay? Those are X values, really, X, and these are all Y's along this whole line here. But this is really my header row here that I need. Okay, now this is just going to be whatever this is. These are horizontal lines. I can copy that and just paste it here. And that's a very easy way to see. Wherever I copy it to, it just says go to one above. Whatever row column I'm in, go to the row above it and pick up that number. So that should be a control chart. Now we select that data and then we find out where the charts are. There it is. We can get rid of this now. We know what's up with that. It's slow because I'm recording this, and it doesn't always work. There's my chart. Okay, none of that. It doesn't look like what I want, obviously. Go into charts. This often helps. We don't want it. we don't want to switch rows and columns. It thinks we do because it only sees 2 values there in 4 series. It's confused by that. But I'm pretty sure column D was our X values for batches. Okay, and use row 3 as headers. I'm hoping that, I think that's right. But we gotta pick the right type of graph. Yeah, that's pretty good. Except, see how it turned off? We want the batch number, that's column D. Since this unchecked itself, it plotted these numbers 1 to 100, right? And we want that as marks along our x-axis. So by doing that, there we go. Took them out of the plot as a series from just the first position to the last position across this chart and actually put the numbers there. Okay, and we want to change this title. Used to be you could just click into there, but at this stage we have to go into customization. Yeah, upper control, and see now these match the blue on top and red and so forth. Okay, so this is going to be a control. Oop. Tried to select that. Control chart. Spike recovery. That's because we subtract the value of the original sample if we put a spike into a sample. Batch number, good. It figured that out on its own on the horizontal axis. But on the vertical axis, we want to put recovery values. And let's put them in microgram because I'm not using percent recovery. And I want to stress that when you do use percent, it should never be multiplied to times 100 the way this is. It should always be a decimal expressed as a percent. And that is done with this little button up here, format as percent. So if I formatted this recovery as a percent, it gets to be 10,000%, which is ridiculous. So I'm not going to get into that. We're not going to call it percent. So I made that mistake there. I'm going back to automatic and bring my decimals down. Now since I brought the decimals down to one place here, it puts the decimals at one place on this chart. I don't want that because it's really not called for. We just want to know what the lines are. And so if you come down here to the vertical axis and scroll down a little bit, major, minor, number format. Do we want it to come from the data or do we want it just to be no format? That's what we want. So that's one way to change that. While we're here, we could change the min and the max to put it to sort of lock this in so it doesn't jump around. Let's look at it jump around. It's easy to change the min and the max in a little bit. When you want to move a chart, I've been sort of clicking in trying to slide right away, and it often doesn't work that way. I'm going to squish this up a little bit, select everything there on the left by clicking into that upper corner, and then let's make these columns squished up a bit so we have more room for the chart. Okay, now there we are. That's a control chart, and we're ready to put points in as we do future batches and we get our spike results. How do they look on this graph? Now something that I need to correct here, catch up with, is this is being named a control chart, right? That's what I asked today, I think. So that'll help me if everybody has that same name there. Now, I want to go back to this chart and add some grid lines. I didn't do that before because I forgot. So we go into Advanced Edit. It's going slow. And we come down to the vertical and the horizontal axes again. The vertical, let's work on the horizontal. So down here we have the min and the max are fine. It's going to leave them at 100. So there's 1, 2, 3, 4, there's 5 lines there, not the origin. What if we put 6? Let's see what that does. 6. Yeah, that's not good, really. So, we could use 9, probably. Yeah, there's 9 and nothing at 0, which is a little odd. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we might want to put, let's see, 4 would make it 10, 11, 12, 13, 14, 10, 12, 14, 16, 18, 20. So 4 lines in between here. That's how this is working. And we can make this one a little darker. And this, that's pretty ugly. Let's make this one a little darker and this one, what happened? That one a little lighter. Okay, so now we can actually look more closely at what batch we're talking about. And I think we can click on this axis here, which is slow. Oh, no, we can't do that here. We have to wait till it's in. So I'm going to also try to work on the vertical axis a little bit. I'm scrolling with my little roller there. Recovery values, major axes. Actually, let's set this now. I don't think we're ever going to get lower than 50. Our lowest control limit's going to be below that, and 150. And so now we have 1, 2, 3. We have 5 major lines. 1, 2, 3, 4, 5. And we want from 50 to 150. Let's just guess. We might want 9, 56. Yeah, that's not bad. And then maybe we want 1 in between each one. And let's make those big ones kind of dark and the 5ers lighter. Okay, so that's not beautiful, but actually we might bold this, make our lines a little thicker, and yeah, okay, I like that a little better. That looks technical. Alright, now we're done. We could print these out and put them at the bench, and if we had a person doing this for us, we'd say, now every day you get your result, you put a little dot on here, connect it with a line, and I'm going to come by and look at them, and if the FDA comes by, they're going to want to see them, so do it right. Alright, now we're going to start getting our results here, and we didn't really plan ahead, so we need, I'll tell you, this is the deal. Since these charts all want to know, with that one little checkbox, where are your X values, it is, I don't think that there's any way to get around putting the X values in column D, where it's asking for your labels. If you don't put them there, I don't see any way that you can avoid trouble. So I'm saying you need to put your X values for your real results down here. So we can go, I think, batch down below here if we want to, batch number. But here's what I'm going to do now. Over here, the header row asks, that's another checkbox, okay? We could put our spike results here. Let's do that. Spike results. And we already know it's micrograms per mil. Okay, so now we're going to do 100 batches. So once again, put in the 1, and this is equal to that plus 1. You can do this how you want. Control C. And now I can hold the shift key down, just lean on the down arrow. We started about 15 or so. Let's go down to 115. Let's pretend this is 7 days a week. Well, let's say 5 days a week for 20 weeks. We've got about 100 results. Control V. Did I copy that? Yeah. Okay, so that's more than enough places. And let's put in these same random numbers. Let's say everything's going to continue the way it was when we did our first 10 runs. Now I'll show you a little trick. I want to get down to 100 real quick. I'd go over here. This is like getting on the banister at the top of the stairs. I hold the control key down and hit the down arrow. Poof. Hit the bottom. Now I could be here, hold the shift key and just jump up to there to delete that. Now we got 100 values. What I want to do, I think, control, let's just check. No, I want to copy that. I didn't paste it. So copy. Now I've copied this formula for random numbers here. I've copied that formula. And it is copied, and it's going to paste where I want to go here. I'm going to start from the bottom, control down. That's sliding down the banister. Then I'm going to jump over here, hold the shift key down, and hold the control button down. The shift will select every place it goes to. The control key will jump all the way to the top. And then I can let go of the control button and come to where I want it to start pasting. I've selected where I want to paste that formula from here, and it didn't matter where I copied from. Control V pastes that into everywhere. Somehow I delete, oh yeah, I wanted them over here. Okay, so I'm at the top of the banister now. I have a new banister beside the one I just went down. Control Shift down arrow, that gets all of them. Control X, that cuts them. Let's see where I want them by sort of just making the sheet show up. And Control V is going to paste that whole set down below here, all the way down. Okay, now my graph sees this much, and so I need to tell it to look at this whole thing. And I'm going to hope that this little batch number, I don't really need that there. Let's see if it does it with it there, and then if we need to delete that, we will. Because a word can screw it up if it thinks it's getting X values that correspond. 100 is way out here. This 100 plots at 100 rather than the first space after 1. But this might appear in the fourth space if it starts considering it like a sequence of numbers rather than XY values. Very important to keep that in mind. Okay, so we're extending our data over to column J here, and we're extending it down to row 107 in the spreadsheet. So J107 is the bottom. So let's go into here. We could select all that data and make a new chart, but we've done a lot of work here, so we don't want to mess that up. So we want to just include now our new results. So we find where it is that data is listed, and here it is. Seems like sometimes it shows up on the recommendations thing, but notice it goes over to column I. We can't move this out of the way very well. We want it to go all the way over from D3 to J10 something. So IJ, that's one column over, J, and instead of 5 we're going down to, let's just say 115. That, we'll see where that gets us. Then if I say update, what's going to happen? Yeah, I think that's good. The blue line is our spike results, and for the most part things look okay, sort of. It's interesting that this sample has a mean that's a little high. Standard deviation is really good, so that control limits would have been average of 100 plus 20 for the upper warning limit and plus 30, but since we're a little high in the mean and a little high in the standard deviation, the actual results seem to average more close to 100, which is what you'd expect because we selected the mean to be 100. Okay, so it's kind of like the control limits that we set up based on this set of 10 values should be readjusted down the road when we get more values that all look normal. This, by using now all 100 values that we've collected instead of just the first 10, I'm going to put little points in here, we get a better placement of our average and our limits. But 10 is a good place to start. And notice out of 100 we expected 5 to be outside the warning limits. We've got 1, 2, 3, 1 touching 4 below the lower warning limit and nothing above the highest warning limit. So everything's in control. But let's just look a little bit. If I click anywhere here and hit Control R, that'll refresh these values. They didn't change much. That's interesting. Let's just watch this and see if everything changed. It did change the patterns here, that we got one result way out here. These look barely inside the warning limit. This touches it. So we're still in that region where roughly 5 results are right near the warning limit. Nothing has gone outside the 3S, but we've been lucky with our standard deviation values here being close to 10. Control R again, and what we're seeing now is kind of like, how good can a control chart get as an estimate for standard deviation when you only have 10 values from which you're estimating? So here now the standard deviation happened to be a little on the low side from this limited sample of QC results. And now we're getting more than 5 out of 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 that actually touch that line, because this estimate is not the greatest. So let's see what would happen now. Let's do that a couple more times. Control R. That's a little too wide. That's not. But it's a place to start. That's the idea here. That's on the wide side. That's on the narrow side. Look, now we got a couple. We'd say, oh my gosh, we started out, and the second time we ran the spike after we made our control thing, we're having to stop. And is there a problem? What do we do? Well, I don't know, but at least you have a guideline. We don't have answers, and that's not the way it works. It's not that clear, but we know we should have gotten 10 here, and random samples from normally distributed numbers are not going to always give us the best estimate. Let's try again. That's not bad. That's worse again. So, a couple times on the low side, things really look terrible. Look, I mean, that's unbelievable. That is really low. That's how bad it can get. Right? In general, it's not great, but like I say, it's a place to start for guidelines. Okay, so you got a feel for how much this varies. And what I'm saying now is let's go ahead. We just need to copy those bottom two and go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Paste, Control V. I got a couple extra in there. We normally wouldn't throw them out, but I said 20, so let's make this go from, instead of B14, let's go all the way down to B24. So we're going to make this B24, and we're going to make this B24 as well. So now the average and the standard deviation are both coming from 20 values. And we're going to see, is 20 is a better place to start? In general, let's just look at this about 10 times. This is kind of like, what if you started with 20 samples and you did it in 20 different, or however many times I'm going to hit Control R. This is kind of how this procedure is going to work for you. See, there it's on the small side again. So standard deviation is very susceptible to inaccurate estimates, not the greatest estimates. And this is the formula where your average square, the square root of your average square deviation, is divided by n minus 1. So that minus 1 adds a little bit to this. It adds 1/20th of a chunk of your total sum of squares. We'll get into that later. But anyway, these are guidelines. This is a place to start. And I want you to do this same thing. Follow what I did here. Put your upper, lower control and warning limits here, and add your spike values here with your batch. Notice the batch number didn't matter. These things got put in the right place. If, for example, I change this to, instead of 7, I change it to 17, that's going to, yeah, that changes all of these. And see, it leaves a gap here. So it is actually plotting these values as XY values. I can just put that 7 back, and since these all depended on it, they all straighten themselves out. The batch didn't cause a problem here, that word batch number. I don't know if this would. Control C, Control V, even the spike results, but I think if we delete it from here, we lose it from here. So we do want to have that in the header row so that it labels our series out here. Okay? That's a control chart, nothing to it. Now, just one other thing. Why didn't somebody tell me? I told you there's this little Explore Data button that shows up, and I'll show you that. It's down here, and I don't know if you noticed it before, but see, when I've clicked into this set of data, there's this little Explore Your Data button. I just noticed it this morning. We click on that, and this is pretty cool actually, because it looks at this set of data apparently, and it gives you the ranges, and it sort of summarizes it. These ranges are from 71 to 126. So I guess that's the range of values here. Most values are around 100, the mean plus or minus 8.8. So the average of these 100 values is right on, but the standard deviation of these values is a little tighter than we would have expected. Whereas the standard deviation of these values, and I don't know if they're going to change, they're always changing, but oh, look at that. It doesn't show us a histogram, it shows us the plot of these values. And isn't that weird? And I don't see why it doesn't show us the histogram. Look at that. So to me, this is wonderful but unpredictable. Maybe the top button matters. Nope. So see, this is a series of how they look like our control chart. Plotting these spike recovery values as a series in the top graph. And then as a sort of a horizontal line graph, there's 20 values there now. Oh, and there's a histogram. So the mean should be 100. That's where the top of the bell-shaped curve should be. So the histogram is the other tool that's going in your toolbox. And there's easy ways to do this. And this is a very sort of easy way that actually did a pretty good job of there. So you click on, looks like the top number or maybe any number in your data set there. Notice this is a pretty nice curve. This little bump here and the little depression there, that doesn't mean anything. So it works on the bottom. What if we hit Control R while we're right here? Get a whole new batch. Hey, that looks much worse. That's got a gap here, but and it doesn't give you X values like it seemed to before. So that's the other tool that we're going to spend time with, because this is a very good way to look at your data. But for now, I think we'll leave it at that. I might have you do this a second time. Do it with these parameters, a mean of 100 and a standard deviation of 10, and then try it again from scratch in a new worksheet, because practice, patience, and persistence need to be a part of what you learn here. Think about it.